today we're looking at 8.2, which is about quotients. So before we begin, I want to remind you that a quotient can be written a couple of different ways. A quotient could be written like this. Something, and then we have a division symbol divided by something else, okay? That's one way to represent a quotient. Another way to represent a quotient, however, is using our fraction line or a ratio, and it would look like this. Okay, so now that we've reviewed the two ways quotients can be represented, I want us to look at this idea in example 1, where they ask us to simplify a quotient. And it says simplify 32 times a cubed divided by 4a. So, using the idea that we can rewrite a quotient that looks like this, and we can rewrite it as a fraction, we're going to do that to simplify on example 1. So, this becomes the numerator, the first part. So we have 32a cubed and then our denominator is the second part what we're dividing by, which is the 4a. Alright, so from here I'm going to expand that a cubed. Okay, so I'm going to expand it. And when I expand, a cubed is the same as saying a times a times a. And now I can do some simplifying. So for example, 32 and 4 simplify. 4 goes into 4 once, and 4 goes into 32 8 times. A goes into a once, and it goes into a once. So now I'm left with 8 times 1 times a times a. And on the bottom, I'm left with 1 times 1. So 8 times 1 is 8. And a times a is a squared. And then 1 times 1 is 1. And then anything divided by 1 is itself. So I end up with my answer of 8 times a squared. Alright, so that is a good example on how to rewrite a quotient as a fraction and then use that to be able to simplify. The quotient property of exponents can also, that we learned in chapter 1, we learned the quotient property. And we can actually take that quotient property that we learned and we can actually use it with variables as well. Okay, so first of all, let's review the quotient property of exponents. So quotient property of exponents. So this property says that if you have a power divided by that same power, by the way, that could also look like this, x over a, x to the a divided by x to the b, right? Because it can work both ways. Then what you're going to do is you are going to subtract your exponents as long as the base is the same. Alright, so the only way this works is if x is not equal to 0. X cannot be equal to 0. Your base cannot be equal to 0. Okay, so in words, the quotient property of exponents says this. To divide bases, or to divide with like bases, you subtract your exponents. All right, let's do an example. We're going to look at example 2. So example 2 wants us to simplify, and it has a very large fraction, right? It has 24 x to the second, y to the 6th, z to the 7th, and it's over, so it's a quotient, negative 8 x, y to the 2nd, and then z to the 5th. Okay, so to do this, the first thing I can do is I can go ahead and I can simplify the 24 and the negative 8, because negative 8 goes into negative 8 once, and then negative 8 goes into 24 negative 3 times, okay? And then I can use my quotient property for the rest of this. So I'm going to end up with negative 3 over 1, and then I have x to the 2nd power, and then this has a first power on it, so minus 1. And then y, there's a 6 and there's a 2, so it'll be y to the 6 minus 2. And then the z, I have a 7 and I have a 5, so z to the 7 minus 5. Okay, so now to simplify, negative 3 divided by 1 is simply just negative 3. 2 minus 1 is 1, so I have x to the first power, which is just x. Y to the 6 minus 2, that's going to be y to the 4th. Z to the 7 minus 5, that's going to be z to the 2nd. Alright, now that we've completed the second example, I want us to recall something from chapter 1, and that was the negative exponents, right? So negative exponents were defined with quotients. So when we had a negative exponent, for example, if we have x to the negative n, chapter 1 says that's the same as saying 1 over x to the positive n. So basically any quantity that had a negative exponent, it was the same as taking the reciprocal and with the positive exponent, okay? So the quotient and product properties that we're learning, that we're working with, they actually prove this. So for example, if I have a squared times a to the negative 6, according to the product property, that says I should do a to the 2 plus negative 6, which is a to the negative 4. Now, if I were to use my quotient properties, well, then a to the 2nd, a to the negative 6, this negative exponent means that it should be written as this, a to the 2nd over a to the positive 6. And if I were to expand that out, I would have a times a over a times a times a, 6 a's down here, right? And then if I were to simplify, a goes into a once, a goes into a once, so I'm left with 1 times 1, which is 1, and then I'm left with 1 times 1 times a times a times a times a, which is a to the 4th. And then 1 over a to the 4th is the same as saying a to the negative 4th, right? So we end up with the same answer. All right, let's do another example where we can prove things with negative exponents. Let's say we have b to the 3rd over b to the 5th. Now, according to my quotient property that we just talked about, I should be doing b to the 3 minus 5, which is the same as saying b to the negative 2, right? Well, if I were to expand this out, b cubed over b to the 5th, that's 3 b's on top, 5 b's on bottom. So if I were to simplify, I'm left with 1 on top and then b squared on bottom. Well, 1 over b squared is the same as saying b to the negative 2. All right, so let's do one more proving thing. Let's take a look at 1 over x to the negative n. Now, 1 over x to the negative n, that's the same as saying 1 over, and then x to the negative n changes to 1 over x to the positive n, right? So this is the same as saying 1 divided by 1 over x to the n. Well, remember when you divide, you multiply by the reciprocal. So that's 1 times x to the n over 1, which is just x to the n. So that proves how we get the negative reciprocal property. All right, so let's do an example using negative reciprocals. Let's say we have a to the negative 2. So remember, a to the negative 2, in order for that to be positive, we have to take the reciprocal of it. So it becomes 1 over a to the positive 2, okay? And then if we have something like this, 1 over 5 to the negative 2, in order for that exponent to be positive, we have to take the reciprocal. So we're going to flip it, and it becomes 5 over 5 to the second over 1, right? So 5 squared is 25, and then 25 over 1 is just 25. Okay, so what I would like us to do now is example 3 in the textbook. And what we're doing is we're writing an equivalent expression in positive exponential form. So we're doing example 3. And there's 3 parts, and we're doing positive exponential form. So that means that all of our exponents need to be positive. So here's part A. We want to do x to the negative 4th, y to the second. Part B is 2x to the negative 2. Part C is negative 3x to the negative 2 to the cubed. And then part D is 1/3 x to the negative 3 to the negative 2. All right, so let's start with part A. So in order for us to have a positive exponent, we need to take the reciprocal of x to the negative 4. Now this y squared, he's fine where he's at. So he is not going to move. We're not going to take the reciprocal of y squared. He actually gets to stay in the numerator. And the only thing that moves is the x to the now positive 4. On part B, this 2 here, he's fine. He does not need to leave the numerator. However, in order for this exponent to be positive, we do need to move that x squared down. Okay, and then for part C, before we start moving things, we need to go ahead and take care of this power, right? So that needs to be distributive. So it should be negative 3 cubed, and then x to the negative 2nd cubed. All right, so the first thing we did was distribute that cubed. Well, negative 3 cubed is the same as saying negative 3 times negative 3 times negative 3. That's going to become negative 27. And then x to the negative 2 to the 3rd, this is the power of a power. And when you have a power of a power, you multiply. So negative 2 times 3 is negative 6. So that becomes x to the negative 6. Now we can go ahead and rewrite this with a positive exponent. So this negative 27, it's negative, but it's not a negative exponent. So he's going to stay in the numerator, while this x to the negative 6, he's going to move so he can become positive. All right, so part D is the last one. So before we move on, we want to go ahead and distribute this negative. So 1/3 to the negative 2 And then we have x to the negative 3 to the negative 2. So now we'll go ahead and distribute this negative 2. So we have 1 to the negative 2 over 3 to the negative 2. And then negative 3 to the negative 2, that becomes positive 6, because negative 3 times negative 2 is positive 6. Now all we have to do is take care of these negative exponents. So the 1 to the negative 2 is going to move to the bottom, become 1 to the positive 2. This 3 to the negative 2 that was in the denominator, it's going to move to the numerator and become 3 to the positive 2. And then we still have x to the 6. And 3 squared is equal to 9. And then 1 squared is equal to 1. And 9 over 1 is just 9. So we have 9x to the 6. Okay, great. Let's go ahead and move on. Let's talk about the exponent of a 0. Just so you remember, anytime you have a 0 exponent, it's equal to 1. Anytime. Okay? And let's think about why this is correct. Okay? Let's say we have x cubed over x cubed. According to our quotient property, that would be x to the 3 minus 3. Well, 3 minus 3 is equal to 0, right? So think about it like this. If I have x cubed over x cubed, if I expand that out, I have 3 x's on top and 3 x's on bottom. So everything is canceling. All right, and if everything cancels, then that means I'm left with 1. All right, so let's do example 4 now. So this one is a little bit long. It says divide 34x to the negative 3, y squared, z to the negative 5th. We want to divide that by negative 18, x to the negative 6, y to the 2nd, and then z to the negative 2. So first thing we can do is let's go ahead and rewrite this as a quotient, as a fraction. Okay, so we have 34, x to the negative 3, y to the 2nd, z to the negative 5th, over negative 18, x to the negative 6, y to the 2nd, z to the negative 2. So the first thing I want to do is I want to go ahead and reduce my fraction, right? So 34 over 18, both of those can be divided by 2, right? So that becomes 18 divided by 2 is 9, well, really negative 9, right? And then 34 divided by 2 is 17, okay? So I do have 17 over 9, but it is negative, okay? And then let's take care of our exponent. I have x to the negative 3 divided by x to the negative 6, which means I need to subtract negative 6. And then I have y to the 2nd divided by y to the 2nd. So I should have 2 minus 2. And then I have z to the negative 5th divided by z to the negative 2. So I need to subtract negative 2. So this is where integers comes into play, right? Because if I have negative 3 minus 6, that's the same as saying negative 3 plus 6. And if I have negative 3 plus 6, then that means that my answer is 3. So it would be x to the 3rd. So this piece right here, if you are having trouble with your integers, go ahead and use a calculator and you'll see that negative 3 minus negative 6 is the same as saying 3. And then we have y to the 2 minus 2, which is y to the 0. And then I have z to the negative 5 minus 2. Well, negative 5 minus negative 2 is the same as saying negative 5 plus 2. And negative 5 plus 2 is the same as saying negative 3. All right, and one more thing before we go. Remember that y to the 0 is equal to 1. So in reality, I have negative 17 over 9, x cubed, z to the negative 3. All right. And if we want to have this as a positive exponential form, like they asked for, if it's a positive exponential, this z to the negative 3 is an issue. So everything else can stay, like everything else can stay where it's at. The only thing that needs to move is the z to the negative third. It needs to move to the denominator so we can have a positive exponent. All right, let's go ahead and talk about the power of a quotient. We kind of did that earlier in another example, but let's review it just in case. So going back to chapter 1, let's say you have a quotient and you have a power of the quotient, right? Well, you can distribute that power. So that's going to be the same as doing a to the n over b to the n. So it kind of gets distributed. All right, so let's do an example using that. We're going to do example 5. So example 5 says simplify y over x squared cubed, and then it has x cubed y to the negative 4 squared. And it says leave all the variables in the numerator. Leave all the variables in the numerator. All right, so let's go ahead and work on this. So the first thing we want to do is distribute this 3 right here. Okay, so I have y to the third over x squared to the third. All right, and then I'm going to go ahead and distribute this 2. So I have x to the third squared, and then I have y to the negative 4th squared. All right, and then I'm going to use my power of a power to simplify that. So remember, that means to multiply. So 2 times 3 is 6, so I have x to the 6. And then power of a power, that's going to become x to the 6th. And then power of a power, that's going to become y to the negative 8, because negative 4 times 2 is negative 8. All right, so to simplify from here, all of this is in my numerator. And notice how I have x to the 6 and x to the 6. Well, it's kind of like simplifying a fraction. X to the 6 goes into x to the 6 once, and it goes into it once. So now I'm left with y cubed times y to the negative 8. Well, using my product property, that's the same as saying y to the third plus negative 8. And 3 plus negative 8 is going to be negative 5. All right, that is pretty much all the properties that we've talked about. There's just one more thing I want to discuss. Whenever you are simplifying, it's important to know that if you have negative exponents in your denominator, that's not simplified, okay? Unless it says leave your negative exponents in your denominator, it's not simplified if you do that, okay? It can be considered simplified if all your variables are in the numerator, okay? However, you usually just want positive exponents. Okay, so if you have negative exponents in your numerator, go ahead and move those to the denominator to make them positive. All right, let me show you some examples of that. We're going to be looking at example 6. All right, and it says simplify. So remember what I just talked about simplifying, what that means, right? So basically no negative exponents, all right? So let's do part A, which says negative 2x to the negative 2 times negative 3xy to the negative 2 all over 12y cubed. All right, so the first thing I would like to do is go ahead and put all my numbers together. So that would be this -2, this -3, and this 12, right? So I have -2 times -3 over 12. All right, and then I want to put all my x's together. So here's one, and then here's another. So I have, this is an exponent of 1, right? So I have x to the -2 plus 1. All right, and then I want to go ahead and put my y's together. So I have y to the -2, and then I have y cubed, right? So since it's division, that's y to the -2. Division means subtract, and then that exponent, 3. All right, so 2 times -3 is -6. So I have -6 over 12. And then x to the -2 plus 1. -2 plus 1 is -1. So I have x to the -1. And then y to the -2 minus 3. -2 minus 3 is -5. So I have y to the -5. All right, so we want to go ahead and simplify. Go ahead and simplify that -6 over 12. That's the same as saying 1/2, right? So 1 over 2. And this x to the -1, remember, we want no negative exponents. So he's going to move to the bottom and become x to the +1, which is just x. And then this y to the -5 is going to move to the bottom and become y to the 5 on the bottom. So I get this as my final answer, 1 over 2 times x to the y to the 5th. All right, let's do part B on example 6, which is 8x squared z to the -3 over y times y c to the -4 over 2x to the 5th all to the -2 power. All right, so first things first is I want to distribute that -2, okay? And so he's getting distribute to everything. So he's getting distributing here, 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 and here. So I still have this 8x squared z to the -3 over y that I'm going to take care of in a minute. But for right now, I have y to the -2. I have z to the -4 to the -2 over 2 to the -2. And then I have x to the 5th to the -2. All right, so from there, let's go ahead and use our power over power rule to multiply. So I still have this 8xz to the -3 over y, but now I have y to the -2. -4 times -2 becomes +8 over 2 to the -2. 5 times -2 becomes -10. All right, so I'm going to go ahead and take this 2 to the -2 and move him up so he can become 2 to the +2, all right? So I move them. Now let's look at our x's. I have just one x, and then I have x to the -10. So I have x divided by x to the -10. So that's x to the 1, because there's a 1 exponent that's invisible there, minus, because it's division, -10. Okay, now looking at my y's, let's go in alphabetical order. I have -2 and I have just 1. So I have y to the -2 divided by, so minus 1y. So that has an exponent of 1, so 1. All right, now my z's. So I have z to the -3 and I have z to the 8th. All right, and those are being multiplied, so that means adding. So I have -3 plus 8. All right, so 2 squared is 4, and then 8 times 4 is 32. 1 minus negative 10 is the same as saying 1 plus 10, so that's x to the 11th. And then y to the negative 2 minus 1, negative 2 minus 1 is negative 3. And then z to the negative 3 plus 8, negative 3 plus 8 is 5, so I have this. All right, so this would be an example of all my variables are in the numerator. So this is actually considered simplified. All my variables are in the numerator, and that's okay. However, also know that if it doesn't say list all variables in the numerator and it just says to simplify, what it actually wants you to do is to go ahead and take that y to the negative 3 and go ahead and move him to the denominator so he can become a positive exponent. So you'll get 32 x to the 11th z to the 5th over y to the positive 3. All right, go ahead and actually, let's see, I think something happened here when we were transposing. Right here, this was an x squared, and we accidentally just wrote x to the first and should be x squared. So that means that should have been 2 right there. So 2 minus negative 10 is actually 2 plus 10, which is 12. All right, go ahead and try some problems on your own.